We're going to do an exercise about pressure in order for you to understand the main idea of exercises related with pressure, but most important of that is how the relation between area and force gets you and helps you to decrease or increase the pressure. So we're gonna do it with it's an easy exercise, but it's very interesting that you think about it. So what I want you to think is that you have a block. Okay, I'm going to do it properly. Imagine that you have a block. Okay, imagine that you have a block, and this block has obviously some dimensions. And the dimensions of the block are 2 centimeters, 4 centimeters, and 6 centimeters. And we know that the block has mass of 10 grams. Okay, it's a very small block. But what I want to do is to put the block in a way that the pressure is minimum. Okay, so how do you think that I should put the block in order to apply a minimum pressure on a surface, for example, on a table or anything? Okay, how should I put the block? That will be the first question. And the second question will be obviously, what is this? What is the pressure? Okay, so essentially what we're going to do is to go to the definition of pressure, and by using the definition of pressure we're going to determine how to get the minimum pressure. Okay, so you need just to remember what is the definition of pressure. So pressure could be defined as force over area. Okay, and here there's a relation that we need to know in any physical situation in order to have a good idea of how to relate information. So first, what we have here is that the pressure depends on the area in an inversely proportional way. So the more the area, the less the pressure. Okay? In this exercise, as we have a mass of 10 grams, so the force will remain constant. So if I keep the force constant, what I'm going to do is to, in order to have less pressure, I have to increase the area. So you just need to think on this block, what option gives you the highest area. So in this case it's simple because you just need to put the highest dimensions of the block on the table and you will have the highest area. So in this case will be when you put the block with 6 centimeters and 4 centimeters. Okay, so we answered the first question. So minimum pressure 6 centimeters with 4 centimeters. Okay, that will be the first answer. Now how to determine the pressure? So we're going to use the same formula, pressure equals force over area, but I'm going to convert into SI units because I know that the units of pressure in SI units are going to give you the units of Pascal. Okay, so maybe you will remember that from another video that I posted about units of pressure. So what I'm going to do right now is just to determine the force and the area. Okay, so in order to determine the force, I'm going to use mass times gravity because I'm going to put the block on the surface, so it will be the weight, the one that applies the force, and the mass is 10 grams, so I'm going to convert it into kilograms. 10 grams converted into kilograms, 1000 grams is 1 kilogram, so I can just simplify to have divided by 1000, so 0.010 kilograms. Okay, and the area, so the length is 6 centimeters, so if I convert it into meters I have to divide by 100, so 0.0060 meters times 0.00 0.060 and 0.040. I was divided by 1000, So in this case, the area will be the multiplication of these two, 0.060 times 0.040, so 0.060 times 0.040, 0.060 times 0.040, 0.0024 square meters. Okay, and the force will be mass times gravity acceleration, so 0.010 kilograms times 9.8 meters per square second. So now essentially what I just have is the force equals 0.098 newtons. Okay, so that will be the force. It's a very small force. That will be the area, a very small area. So the minimum pressure will be just the division of these two values, 0.098 newtons over 0.0024 square meters. Okay, so just divide. .83333 pascals. So 40.8333 pascals. Now, in order to finish, remember to apply significant figures. In every exercise you have to apply significant figures. Okay, this is part of how physicists show answers. So count the number of significant figures. We're doing a division. We have two significant figures here, two significant figures here. So our answer should have two significant figures. So the final answer will be the pressure rounded to 41 pascals. Okay, 41 pascals. Look at that, 41 pascals. You may think that, okay, 41 pascals, how to determine that? But look at that, it's a small number compared to, or if you think of the pressure that we're exerting, it's a small block on a table. You can put it on your hand and feel it, and that will be 40 pascals. Okay, it's very small number, but it will be the value of the pressure. So remember, what you have to think about, if in any exercise you're asked to find maximum pressure or minimum pressure due to a block, due to a surface, due to anything, remember that the pressure is inversely proportional to the area. So the more the area, the less the pressure. If it's at the minimum, so try to find out the highest area possible. Okay? And in this case, you just need to compute. Remember to keep same units in order to get, sometimes I propose to use SI units. So because if you use SI units, you will have the opportunity to have your answers in SI units. So you don't have to think of the units, like, okay, what is the unit if I divide centimeters, meters? No, if you did everything with this SI unit, so the answer is in SI units. Finally, find the value according to the equation of force over area for pressure. Okay, so I hope that this video helped you with understanding how to determine pressure, and I hope that this video helps you to know how to solve problems using pressure. So I hope that it helped you. See you in the next video. Bye bye.